Hello, friends. Today, we're going to talk about some exciting new advances in robotics research that are bringing us one step closer to a future where robots can truly be our helpful companions. Imagine a world where you could simply ask your personal robot assistant to tidy the house or cook us a delicious, healthy meal, and it would understand and carry out those tasks with ease. While this may seem like science fiction, in this video, we'll explore three cutting-edge technologies: Auto-RT, Sera-RT, and RT-Trajectory, which build upon the groundbreaking Robotics Transformer's work. These advancements aim to help robots make decisions faster, better understand and navigate their environments, and ultimately, become more capable and helpful in our daily lives. First, let's talk about Robotic Transformer 2, or RT2 for short. This is a novel model that combines vision, language, and action in a way that allows robots to learn from both web data and real-world robotics data. By merging these two sources of information, RT2 can translate its knowledge into generalized instructions for robotic control, while still retaining the ability to recognize visual or language patterns across different languages, just like the large language models and visual language models we use on the web. You see, for robots to achieve the same level of competency as humans, they would need to collect data firsthand, across every object, environment, task, and situation imaginable. But with RT2, robots can learn from the vast amounts of information available on the web, as well as from real-world robotics data, making the learning process much more efficient and scalable. Now, let's move on to Auto-RT, a system that harnesses the power of these large foundation models, like language models and visual language models, to help train robots for the real world. Auto-RT combines these models with a robot control model, like RT1 or RT2, to create a system that can deploy multiple robots simultaneously, each equipped with a video camera and an end effector, like a gripper or tool. Here's how it works. For each robot, a visual language model helps the robot understand its environment and the objects within sight. Then, a language model suggests a list of creative tasks the robot could carry out, like place the snack onto the countertop. The language model also acts as a decision maker, selecting an appropriate task for the robot to execute. Over the course of 7 months, the Auto-RT system safely orchestrated as many as 20 robots at the same time, and a total of 52 unique robots, in various office buildings. This allowed the system to gather a diverse dataset comprising 77,000 robotic trials across 6,650 unique tasks. By collecting more experiential training data, and more diverse data, Auto-RT can help scale robotic learning to better train robots for the real world. Next up, we have Sera-RT, which stands for Self-Adaptive Robust Attention for Robotics Transformers. This system takes the powerful Robotics Transformer models, like RT2, and converts them into more efficient versions. You see, while transformers are incredibly powerful, they can be limited by computational demands that slow down their decision-making. The attention modules that transformers rely on have a quadratic complexity, which means that if a robot's input doubles, say, by giving it additional or higher resolution sensors, the computational resources required to process that input rise by a factor of 4, slowing things down. Sera-RT solves this problem using a novel method called uptraining, which converts the quadratic complexity to a mere linear complexity. This sharply reduces the computational requirements, making the models faster without sacrificing quality. In fact, when applied to the state-of-the-art RT2 model, the best Sera-RT2 models were 10.6% more accurate and 14% faster than the original RT2 models, after being provided with a short history of images. And because Sera-RT doesn't require any additional code, it can be easily applied to various open-source linear variants of transformers. The benefits of Sera-RT extend beyond robotics. For example, when applied to point cloud transformers, used to process spatial data from robot depth cameras, Sera-RT more than doubled their speed. With its robust theoretical grounding, Sera-RT can be applied to a wide variety of transformer models, potentially massively scaling up the use of transformer technology across different fields. Finally, let's talk about RT-Trajectory, a model that helps robots generalize their understanding of tasks and motions. While it may be intuitive for humans to understand how to wipe a table, there are many possible ways a robot could translate that instruction into actual physical motions. RT-Trajectory solves this problem by automatically adding visual outlines that describe robot motions in training videos. It takes each video in a training dataset and overlays it with a 2D trajectory sketch of the robot arm's gripper as it performs the task. These trajectories, in the form of RGB images, provide low-level, practical visual hints to the model as it learns its robot control policies. In tests on 41 tasks unseen in the training data, an arm controlled by RT trajectory more than double the performance of existing state-of-the-art RT models, achieving a task success rate of 63%, compared with 29% for RT2. Traditionally, training a robotic arm relies on mapping abstract natural language instructions, wipe the table, to specific movements, close gripper, move left, move right, making it hard for models to generalize to novel tasks. But with RT trajectory, robots can understand how to do tasks by interpreting specific robot motions like those contained in videos or sketches. And the best part? RT trajectory is versatile. It can create trajectories by watching human demonstrations of desired tasks, or even accept hand-drawn sketches. And it can be readily adapted to different robot platforms. By making use of the rich robotic motion information that is present in all robot datasets. So, there you have it, folks, Auto RT, Sarah RT, and RT trajectory, 3 groundbreaking technologies that are paving the way for the next generation of robots. By helping robots make decisions faster, better understand and navigate their environments, and generalize their understanding of tasks and motions, these advancements bring us closer to a future where robots can truly be our helpful companions. Imagine the possibilities: robots that can tidy our homes, cook delicious meals, assist with household chores, and even provide companionship and support to those in need. With continued research and development, the possibilities are endless. So, stay tuned, because the future of helpful robots is closer than you think.